As you watch this, swaths of the astronomy community are engaged in the greatest treasure hunt in over a century. Somewhere out on the fringes of the solar system, it's thought a massive object might lurk, one we've so far only been able to indirectly sense thanks to its gravitational effect on several smaller objects, but which may soon be sighted directly. A hitherto unnoticed planet that would represent the first new addition to our cosmic family in living memory. Known imaginatively as Planet 9, this invisible world is currently only theoretical. But since it was first proposed in 2016, evidence has been stacking up that it may be out there. Evidence that suggests we might soon have to rewrite the entire history of the solar system. I mean, at least that's the hope. The planet-sized pot of gold tempting astronomers to keep following this cosmic rainbow, yet as we're about to see, the science surrounding Planet 9 remains unsettled. It could be humanity's next great discovery, or it could be something far weirder. Join us today as we turn our attention to the edges of our solar system and try and separate fact from fiction regarding our missing neighbor. Ironically, the idea of a missing ninth planet was born at the exact same moment astronomers were reducing the official tally down to 8. The era was the beginning of the 21st century, an era that had seen a cascade of discoveries about the outer solar system, along with major controversy. First, the discoveries. Back in 1992, scientists have finally confirmed the existence of the Kuiper Belt, a ring of objects beyond the orbit of Neptune filled with icy bodies. But it was only as the new century dawned that the size of some of these bodies started to become clear. Between 2002 and 2005, researchers led by Mike Brown cited 6 dwarf planets that rivaled Pluto. It was this last fact that sparked controversy. With one of the newfound dwarf planets, Eris, having a greater mass than the former ninth planet, astronomers began to question whether poor old Pluto is even really a planet at all. Infamously, this led to a 2006 meeting of the International Astronomical Union, where attendees narrowly voted to strip Pluto of its status. Yet even as kids everywhere began unhappily redesigning their science fair solar system models, there were already signs emerging that there might be a ninth planet after all, that while Pluto may be too small to really count, that didn't mean there wasn't another, larger world lurking out there. The first clue came from one of the new dwarf planet candidates, Sedna. Unlike Pluto, Eris, or other newcomers like Makemake or Haumea, Sedna didn't behave like a regular Kuiper Belt object. Instead, it had an extremely weird orbit, one that took it from a closest approach to the Sun of 84 AU, where 1 AU is the distance from Earth to our star, all the way out to a furthest point of 937 AU. A bizarre, elongated orbit that takes over 11,000 years. At the time, it was assumed that Sedna was simply a weird one-off, a freaky little world doing its own freaky thing on the outskirts of the solar system. But then we began to locate and investigate more and more objects in the region, and it started to look like maybe Sedna wasn't alone. Trans-Neptunian objects, or TNOs, is the name given to small, icy bodies just beyond the orbit of Neptune. Leftover building blocks of the solar system, they're often quite hard to detect. Although we think TNOs larger than 100 kilometers may number in the hundreds of thousands, so far we've only located about 4,000 of them. But even with this small sample size, we can see that some of them behave in ways our model of the solar system doesn't predict. First, there are the detached TNOs. Accounting for about 10% of all TNOs, these little dudes have orbits that aren't influenced by Neptune. While our models say a few should exist, it's very hard to account for the sheer number of them. Next, you have a bunch of TNOs with orbits at wild angles. That means they zip around the sun at a tilt of more than 45 degrees, another thing our models don't predict happening on such a large scale. Finally, there are the TNOs with such odd orbits that they're sometimes dubbed ETNOs, extreme trans-Neptunian objects. Numbering about a dozen, they're scattered in such a wild way that some new gravitational source is seemingly needed, something that threw them out of alignment in the distant past and now keeps them trapped in their eccentric dances. For Caltech astronomers Mike Brown and Konstantin Batygin, there was one simple explanation. In 2016, they published a paper suggesting Sedna and 5 other ETNOs were likely being influenced by a hidden world, one with between 5 and 10 times the mass of Earth. In short, a missing ninth planet. In the 7 years since that cosmos-shaking announcement, the theory has been refined. Today it's thought that Planet 9 is smaller than originally estimated, closer to 6 times the mass of Earth rather than 10. There are also now 11 TNOs identified as having been perturbed by its orbit rather than just 6. Still, the basic outlines of the theory remain intact. The idea that there may be a whole other world beyond Neptune, a neighbor humanity has remained ignorant of, even as we've gained the ability to detect planets in other solar systems. If that's the case, and another planet is really there, then it raises an obvious question. What's it like? Planets in our solar system are divided into three distinct categories. You have the rocky terrestrial worlds, Earth, Venus, Mars, and Mercury. Then you have the gas giants like Jupiter and Saturn. And finally, you've got the ice giants, including not just Neptune, but also the gassy glory that is Uranus. If you were feeling generous, you could also add to that list the dwarf planets. But the main point isn't whether our solar system contains 3 or 4 classes of worlds, but that, whatever the true number, finding Planet 9 would increase that total. That's because Planet 9's estimated mass falls between that of Earth and Neptune, meaning one of two outcomes is likely. It's either a rocky super-Earth or a gaseous sub-Neptune. Either way, finding it would be extremely exciting. Imagine for a second how paleontologists would feel finding a living mammoth. Right now, we only know these creatures from traces left over from bygone eras. To suddenly go from working with vague outlines to having a living creature to study would be pretty mind-expanding. In a way, that's sort of how planetary scientists would feel discovering a sub-Neptune in our backyard. Obviously, the analogy isn't perfect. Sub-Neptunes are extremely common across the galaxy, whereas living mammoths are uncommon to the point of being non-extinct. Still, it hopefully gives you some vague idea of how awesome such a find would be, how it would help unlock the secrets of planetary formation in both distant star systems and inside our own. And that last point there is key. So far from the Sun, there's no way a sub-Neptune or super-Earth could have been created where it now orbits. Instead, it must have been born closer in, only to be flung outwards during an era of chaos caused by Jupiter's early movements. Some think the reason Uranus is tilted on its side is due to a chance interaction with a migrating Planet 9. Alternatively, it might have once belonged to another star, only to be captured by our Sun's gravity as the two systems swept by one another long ago. Of course, this is all just speculation. A towering edifice of theory built atop a bunch of extremely distant objects moving in some weird ways. Yet that doesn't mean the foundations for this tower aren't solid. After all, humanity has already made major planetary discoveries based on orbital disturbances. Most famously, this includes discovering Neptune. Ever since William Herschel first stared hungrily at Uranus, people have been aware that Planet 7's orbit was kinda off, like something big was influencing it. In 1846, Urban Leverrier did the calculations and pinpointed exactly where that unseen object was. The same evening, he alerted a German astronomer, and Neptune was discovered. It's an episode that shows the value of paying attention to seemingly small irregularities. Consciously or not, today's astronomers are all hoping to repeat Leverrier's trick and discover Planet 9. That is, if we haven't discovered it already. In the cases of Uranus, Neptune, Pluto, and Eris, all 4 bodies turned out to have been sighted long before their official discoveries, albeit by people who didn't realize what they were looking at. Neptune, for example, was recorded by Galileo in 1612, but mistaken for a star. A photographic plate of Eris, meanwhile, has been found dating to 1955. That means there's a fair chance that if Planet 9 exists, signs of it are already hiding in some forgotten or overlooked data somewhere. We even have a potential candidate. Back in 1983, astronomer Michael Rowan Robinson undertook a planet-hunting expedition using the very first infrared space telescope. At the time, he thought he'd found nothing, but after Brown and Battigan published their Planet 9 theory, he went back and revisited his work. There he found 3 potential matches for the missing world, although the low quality of the detections makes confirming them impossible. And that last point brings us neatly on to our next chapter. With 7 years of searching under our collective belts, you might be starting to wonder why, if we know roughly where it should be, we haven't found Planet 9. The answer, sadly, is that finding a missing planet at such distances, even one close in size to Neptune, is near impossible. After refining their work, Brown and Battigan recently made a welcome announcement. Rather than an orbital journey of more than 18,000 years, they instead expect Planet 9 to circle the Sun once every 7,400 years. That means it should be closer and brighter than initially anticipated, and therefore easier to see. In theory, the news was great. Slicing over 10,000 years off an object's orbit sharply reduces the amount of distance it covers. In practical terms, though, an object that takes over 7,000 years to orbit the Sun is still capable of traveling very, very far away from us. Pluto's orbit, for comparison, takes under 250 years. And while Sedna's 11,400-year orbit is longer than Planet 9's, Sedna was discovered when it was near perihelion, the point when an object is closest to the Sun. By contrast, Planet 9 is thought to currently be at its furthest point. That means looking for a very, very tiny speck moving very, very slowly against the Milky Way starfield. So far from the Sun, the missing world will be reflecting very little light, making it hard to detect in visible wavelengths. Its temperature is also likely to be very, very low, perhaps causing it to only radiate the far infrared spectrum. The word far there is the important part, because it means it will be invisible to even the James Webb Space Telescope, which isn't capable of observing things in the far infrared range. Indeed, observing extremely distant things in infrared can come with its own set of problems. A 2022 study by Sedgwick, Chris, and Sargent, reported in Universe Today using 2 infrared sky surveys taken 20 years apart, initially found 500 potential candidates for Planet 9 in the data. But when they dug into them individually, they found the majority were galactic cirrus clouds of interstellar dust that radiate in infrared. Since Planet 9 is assumed to currently be hidden by the Milky Way starfield, such false positives would plague any search. Now, these are not insurmountable problems, but overcoming them will require not just superhuman patience and lots of telescope time, but also knowing exactly where to look. When we say something like Planet 9 is currently moving against the Milky Way starfield, it can be a little misleading, as it makes it sound like we've got a rough location. But this location is rough in the same way that dropping a marble out a jet flying over the United States and declaring it landed in the Midwest is. Sure, it's technically correct, but it won't really help anyone wanting to track down and find that marble. As 2 planetary scientists explained in an article for Conversation, the problem is that these telescopes usually have a very small field of view. It is like using a microscope to scan a very large area for something small that we've dropped. This helps explain why so many searchers since 2016 have come up empty-handed. Space Australia helpfully listed some of the key instruments and surveys so far used: the WISE telescope, the GAIA spacecraft, the TESS telescope, the Dark Energy Survey, and the Catalina Sky Survey, as well as looking through old data from stuff like the Siding Spring Survey and the Zwicky Transient Facility Survey. All turned up nothing. Nor is it really possible to use the orbits of TNOs disrupted by Planet 9 to pinpoint its location. Because we know comparatively little about the Kuiper Belt, it's tough to really zero in on objects that are behaving in weird ways and draw conclusions from them. If we could see and understand the belt's whole structure, we would be able to pinpoint areas where a large planet has disrupted things. At the moment, though, we're working with around a dozen objects that may seem to be orbiting weirdly just as a side effect of selection bias. If that's the case, then Planet 9 may be nothing more than a ghost in the data, a phantom conjured by squinting at a blurry and incomplete picture and hoping desperately to see something. Luckily, combining old surveys and simply pointing telescopes at chunks of the night sky and hoping aren't the only ways to track down a missing planet. It may be that we're soon able to narrow down our hidden neighbor's location using some pretty clever methods. As Elton John once sang of Mars, Planet 9, in fact, is cold as hell. But you know what might not be so cold? Any moons the planet has. Of all the planets in our solar system, only 2, Mercury and Venus, do not have any moons. That means it's highly likely Planet 9 has some companions on its lonely journey through the void, especially when you consider the region it inhabits is full of TNOs. As the most massive gravity source around, it would be amazing if Planet 9 hadn't captured at least a few TNOs over the years. Just look at Neptune. There are good reasons to believe its large moon Triton is a former dwarf planet dragged into the ice giant's orbit. At this stage, you might be wondering why all of this matters. Surely any moon so far away from the sun is going to be equally cold and therefore even harder to see than its host world. Well, perhaps not. Education University of Hong Kong scholar Man Ho Chan recently released a preprint paper examining the role of tidal heating on any moons Planet 9 may have. Tidal heating is a super interesting thing, even for laymen such as ourselves. The result of gravity pulling on an object in a non-uniform way, creating friction and thus heating, it's thought to be the mechanism that keeps subsurface oceans liquid on moons like Enceladus, Europa, and Triton. In this case, though, the paper isn't concerned with liquid water, but with the heat that would be released from this process. That would make Planet 9's moons potentially hotter than the planet itself, meaning it would stand a better chance of picking them up in infrared surveys of the night sky. It's a fascinating concept, and just one of a recent slew of bold theories put out on how we could detect the invisible world. Another involves using an even wider mechanism, the path of an interstellar asteroid. CNEOS 2014-0108 is most famous as the meteor that crashed offshore in Papua New Guinea in 2014 and later became the target of a sea dredging expedition led by R.V. Loeb, who claimed that it might be a piece of alien equipment. But whether or not it's the stuff of Fox Mulder's wet dreams, it may have a far more prosaic use. According to Hector Socas Navarro and Ignacio Trillo Cabrera of the Institute de Astrofísica de Canarias, by tracing its path back across the solar system, we can see whether it interacted with a large object on its way. In 2023, they published a paper doing just that. In it, they demonstrated how the asteroid likely came from the region of space where Planet 9 is most likely to be located. If the planet is indeed there, then the odds of the meteor interacting with its gravity are something like 99.9%. That means, if we can figure out when CNEOS 14 entered our solar system, we can plot its trajectory backwards and pinpoint where Planet 9 was when the meteor brushed by. Socas Navarro and Cabrera think this places the missing world, quote, very close to the point where the constellations Aries, Taurus, and Cetus meet. Now, to return to our analogy from the last chapter, having confirmation of this world would be like narrowing our airplane drop marble's location down from the Midwest to somewhere in downtown Des Moines. Still a huge area to search, but one that's now in the realms of possibility. But perhaps the Planet 9 location mission we like the most is the one that would involve probing Uranus. The most recent decadal survey selected as highest priority for NASA a dedicated mission to Planet 7. When it finally launches, assuming the US Congress can settle down long enough to start funding science again, the craft will spend between 10 and 15 years simply traveling through the void between Jupiter and its target. Rather than an annoying pause, though, that decade could prove invaluable to science. When an interplanetary craft is on a long cruise like that, it occasionally checks in with a station on Earth, just a call to say where it is and how it's doing so we know it's not about to go flying off course or activate any hidden monoliths or anything. Normally these pings are relatively rare, but if we could make the Uranian probe fire off enough, we'd be able to see over time how Planet 9's distant gravity affected the craft. It would be a subtle effect, a near invisible tugging, but it would also be enough for us to use that data to narrow down Planet 9's location, perhaps enough so that astronomers could even be convinced to start pointing powerful telescopes in that direction, knowing that they had a decent probability of finding something. Of course, NASA won't be ready to investigate the majesty of Uranus for several years. That means there's a good chance we'll have located the planet long beforehand. The Vera C. Rubin Observatory in Chile is currently the most exciting science project not enough people are talking about. An 8.4-meter telescope, it will photograph the entire visible night sky every couple of days, producing mountains of data that researchers will be able to sift through looking for signs of unknown objects. If Planet 9 really is out there, this is the most likely way we'll find it. What if it isn't? What if the Vera C. Rubin comes online only to return nothing, a void where the missing sub-Neptune should rightly be? Incredibly, that might be even more exciting than actually finding it. Perhaps the most interesting thing about Planet 9 is its inherent sense of mystery. The feeling that it could be the world Brown and Battigan theorized back in 2016, or it could be something totally different. You know how you sometimes see images of old maps that drew on hypothetical Australia before it was ever actually sighted? Well, that's kind of where we are with Planet 9. We think it's out there. We think we know roughly where it is. Beyond that, we might as well just write, "Here be mysteries." So if it turns out the Planet 9 isn't a missing super-Earth or a sub-Neptune, what might it be? The sanest theory is that it really is a planet, just not one on the scale that Brown and Battigan imagined. The trouble with a sub-Neptune is that it would be by far the most powerful gravitational force in the region. So powerful that models predict it would mess up the orbits of far more TNOs than we're currently witnessing. In 2023, this led planetary scientists Patrick Sophia, Loic Likwawa, and Takeishi Ito to theorize in a paper published in the Astronomical Journal that Planet 9 might be smaller, small enough to be comparable with Earth. Their research showed that a planet a mere 1.5 times the mass of Earth, orbiting between 250 and 500 astronomical units from the Sun, could account for all the weird TNOs that we're aware of, especially if its orbit is tilted to 45 degrees. That would make Planet 9 not some hidden giant, but a real-life Mondus, a near twin of our world, likely cast outward at some point in the early solar system to the icy realm of the Kuiper Belt. This, though, is just the sanest explanation. Further up the weirdness scale, you'd get to what will likely be the most exciting outcome of all, that Planet 9 is actually a primordial black hole. Way back in 1971, Stephen Hawking theorized how the extreme environment created just after the Big Bang could have created pockets of matter so dense they collapsed into black holes. Unlike regular black holes, which are born of collapsing stars, these primordial versions could be anywhere in the universe. They could also be much smaller, beach ball-sized things with the mass of a planet. To date, we've never seen any evidence for these objects, all of which makes the idea that they might be lurking out there on the edges of our solar system immensely exciting. Aside from proving Hawking's theory, such a black hole would also be close enough for us to potentially send a probe out to study it, something we likely won't have the tech to do with regular black holes for hundreds or even thousands of years. The downside of Planet 9 really being a black hole is that it would be insanely hard to detect. Aside from giving off no light, a primordial black hole would also be small enough to fit into a backpack. Rather than searching for a dropped marble in the Midwest, this would be like searching for a single grain of sand. As a paper on phys.org noted, this small size would make gravitational lensing and gamma ray emissions too faint to register. Once again, though, the Vera C. Rubin Observatory could well ride to the rescue here. According to a paper by Avi Loeb and Amir Siraj, small comets would ride into the path of such a primordial black hole at least a couple of times a year. When that happens, they would be ripped apart, producing a momentary flash. A flash the observatory should be able to see. As Loeb told the New York Times, quote, "Our calculations show that the flares will be bright enough for the Vera Rubin Observatory to rule out or confirm Planet 9 as a black hole within 1 year of monitoring the sky." Currently, regular observations by the telescope are expected to start in 2025. That means we could have a definitive answer before this video has even been up on YouTube for 3 years. There are other theories too, that Planet 9 may actually be a clump of dark matter, that it could be the exposed core of a world long ago destroyed. But time is running short, and we need to stop this video somewhere. So that's how things stand at the moment, with a mystery on the edge of our solar system, one that's bedeviled scientists for 7 years now, and may do so for several more years to come. In a way, this makes our era an exciting time to be alive, an era when we may be standing on the cusp of a great discovery, one that would capture the world's imagination in a way unseen since Urban Le Verrier accurately predicted Neptune's position in the night sky. On the other hand, it also makes this something of a frustrating game, knowing that there's a great mystery out there waiting to be solved. One future folk will take for granted, but which, for now at least, remains stubbornly out of our grasp. What the coming years will hold for the hunt for Planet 9 remains to be seen. But we feel confident in saying that whatever happens, it will undoubtedly be a search to remember.